So I like to do this. I like to put here on the side three things: mass, molar mass, and
Mole.
moles. Are you familiar with these letters?
Yeah, yeah, yeah.
So this is mass, this is molar mass, and this is moles.
Yeah, and then molar mass and then mole. But yeah.
Okay, and what we're gonna do is we're gonna make a little table here. And you can use this table for everything, including excess and limiting. You can use it for everything.
Okay.
This is my table. Teachers don't do it this way. This is the way that I figured to do it. And I'm not saying I'm the only person that did it, but I'm pretty damn confident that um, it's pretty good method. So let's say just hypothetically,
Yeah, my teacher does like the three-step method, like or
it's the same
something.
thing. Let's say that you have
Okay.
4.51 grams of hydrogen,
Okay.
and the question is, how much oxygen do you need? And also, I want to figure out how much water is produced. So I'm trying to fill in these
Okay.
yellow boxes. So what I want you to do is think about how to get the moles of everything, because it all comes down to moles. It all comes down to moles for these things. So what I'm going to do now is ask for the most obvious thing from you, molar
The
masses.
molar mass?
Those are easy to find. Those are just look them up, right? So H2, I'm not going to do it with you. I'm just going to tell you the answer because you do these all the time now. So instead of writing the units here,
Yeah, I have
I'm
my
going to write the units in the margin here
okay.
because it's too annoying. Now oxygen's
Yeah.
32 and
Mhm.
water is 1802. So all you
Okay.
got to remember with this table, Angie, is when you go down, you're going to divide, okay? And when you go up the table,
Okay.
you're going to multiply. Can you remember that? When you go down the
Yep.
table, you divide, and when you go up the table, you multiply.
Okay.
All right. So take 4.451 and divide by 2.02. What do you
Okay.
get? I'm gonna get my calculator. Just do the math there.
It's 2.233.
Okay, 2.23 is good. I'm not gonna concern myself too much with
Yeah.
significant digits here, but I'll put a little bit extra. 2.232, 2.2326.
Okay.
7, sorry. Anyway, whatever. Okay, now what we're gonna do is we're gonna find out what the moles are for these guys. So to go from here to here, I need to do what? I need to divide by 2 because you see it's a 2-to-1 ratio.
Yeah.
So take that number and divide by 2. 1.116,
Yeah.
1163, and then this to here is going to be also, well, this number here, what's this box going to be?
The total moles. Total amount of moles.
Use the ratio, Angie. If there's a 2 here, there's a 2 here.
Oh, two to like it's just two to like 1 to 1 pretty much. Like
Yeah, it's 1-to-1.
so it's the same thing.
It's the same thing. And now, how do you go up the table?
Multiply.
So multiply this times this,
Okay.
and give me 2 decimals. I got 30 something. What'd you get?
Times 18. I got 40.23.
No, no, no. 32 times 1.11.
Oh, that's what we're just multiplying. I see. Yeah, I got that.
Okay, and then the other one, I'm doing sig figs as well here, of course.
That one's 40. I just calculated it.
Yep, 40.2.
40.2.
Okay.
Yeah.
Now this question was basically defined by here. But
Okay.
what if you had some of this and some of that? The chances of them being perfectly balanced out is basically 0. The chances of them being like
Yeah.
exactly in the right proportion is basically 0. So what do? you need to figure out which one is going to be excess and which one's limiting. In other words, one of them is going to have leftovers. So that's what the
Okay, and then
question
one's
about
gonna be like
excess.
not enough.
One of them, well, one of them you're gonna run out of. One of them's gonna run out, and that's the one that's
Yeah,
limiting.
like it's not gonna be. Okay.
Let's talk about excess and limiting, and then after you have this, then you're done. This is
Okay.
really
We
this.
also did this.
Sorry, go
We
ahead.
did the stoichiometry thing with like Avogadro's number two. I
I'll
don't
forget
know
that.
why
That
we did
no,
that,
that's
but
BS. Don't worry about the Avogadro stuff. That's just in the beginning. But what you need to really just do is this, because they might ask you moles,
okay.
atoms. It's stupid. Don't worry. This is the key. Yeah, that's just counting
Okay.
stuff. Forget the counting stuff. This is where it actually matters. Let's make something else. Let's make ammonia. So we're going to take nitrogen gas and
Okay.
hydrogen gas, and we're going to make NH3.
Yeah.
So we'll balance this quickly here. I think it's balanced. No? You agree?
Yes. No.
It's
Don't you need?
balanced.
Oh yeah, it's
Two,
balanced.
2, 6, right? 2, 6.
Yeah, yeah.
Okay, and now I'm going to do the following. We're going to do the same analysis. I'm not going to ask you which one's excess, which one's limiting. I'm just going to do the analysis, because this basically
Okay.
covers what you need to know. So mass, molar mass,
More
moles.
math.
Okay?
Yeah.
Molar mass of nitrogen. N2, please.
It
I got
is
2802.
14.01, so then 18.02,
2802, double,
right?
right? Yeah.
Oh, yeah, yeah, yeah.
That's 202. And then NH3,
Uh,
1704.
yeah.
Okay, so all of this stuff here is the stuff that you should do first because it's easy.
Yeah.
Balancing it and putting all this stuff out of here. Now, I'm going to tell you the question. We're going to have, I'm doing the math on the fly in my head, so bear with me. We're going to have 40 grams of this stuff. I'll make it 41 grams of this stuff.
Okay.
And that's one and a bit. And I'm going to have 8.7 grams of this stuff. Actually, 8.71 grams. So this is going to be 41.1 grams. So the grams are understood
Okay.
because I would write them in the side here.
Yeah.
So we're going to find out two things. Three things, actually. I want to know which is limiting,
Okay.
how much is left over of the other one,
So the excess.
and what mass of ammonia could theoretically be produced. So theoretically means the most that you could possibly get. So that's called the theoretical
Okay.
mass. There's also something called the actual,
Okay.
but that's basically that would be told to you. Like in theory, you could have 100, but when you go and do the experiment, you only get 90. So then they'll say, oh, it's 90%.
Okay.
It's 90% realized or whatever they say. Okay, let's get
Okay.
the moles of these, please. So divide these separately. So what's 41 whatever divided by that? So I got 1.466, 467.
Yep, I got the thing. Yeah, six,
And
seven.
then the other one,
Okay, 8.71
4.312.
Yeah.
All right, so here's the question now. Which one of these two is excess and which one's limiting? What do you think? Well,
I
which
think
number's bigger?
hydrogen's excess. I think
Well,
hydrogen is excess.
yeah, actually, the answer is not clear yet. I was trying to trick you because you
Oh,
cannot make a fair comparison this way, Angie. You see here, there's a 1 and there's a 3. In other words, you need 3 of these
yeah.
guys when you only need 1 of those. So to do a fair
Okay.
comparison, you have to do a little fight. Ready for a fight? You're going to do
Yeah.
1.467 but you're going to divide by its coefficient, which is 1. And then you're going to go versus, you can say versus here, like a fight, 4.312 divided by 3.
Under 3.
Okay.
Yeah.
Now, the first one's a joke because it's just the same. Can you do the second one on your calculator?
Sure. 4.312 divided by 3. It's 1.4373. So
Oh my
1.437.
goodness. See that?
Oh, so I was wrong.
You see how close it is?
Yeah.
So hydrogen, you were right. Hydrogen was limiting, but not because of this number. It was because of this number. See that?
Yeah, because I just looked to see which number was like bigger or whatever, but yeah, I
So
understand
this is
now. So the
limiting.
bigger one is excess and the lower one is limiting.
So back here, which is limiting? Hydrogen's limiting. And this is the key.
Okay.
Remember over here, we used this number and we jumped around the table?
Yeah.
Which number was critical to jumping around the table? This number was the critical number. This is the
That
number that told us
Yeah.
everything, right? It was kind of like our currency.
Mhm.
It's like, imagine you're talking about money, right? If I tell you I have $400 American, I can go to any currency in the world with that. See, this is my American dollars, and then I can go anywhere. Once I have one
Mhm.
currency, I know everything. Well, for this question, the most important number in this entire table is this number. It's the
That
limited one.
number.
This is the one that defines everything. This tells you how much of everything you need. So when you fill the
Yeah.
table in now, you need to use this number to be fair. So what you're going to do now is you're going
Gonna
to,
multiply
let
that?
me just add another pen here. You're going to take this number and you're going to hop around the table. So how do you go from here to here?
Yeah.
You multiply
divide.
by 3 over 2. You see that?
Oh, okay.
Oh, sorry, 2/3, 2/3. You multiply by 2/3
Why do you do that?
because there's 2 to 3.
Oh, because NH2, yeah. Oh, I see.
So what's 4.312 times 2/3? I'm doing it on my calculator, don't worry. 2.875.
Yeah.
And then guess what? You go up the table.
We
Because
multiplied
whatever you
those.
multiply to go up the table. You knew that already?
Yeah.
So
So we
multiply by
multiplied 2.875 times 17.04.
17.04. Yeah, shoot. What do you get? I got 48.9. Can you confirm?
Yes. 48.99.
Sorry, I typed something wrong on my calculator. 48 point, so 49.0. So the answer to this question,
Yeah, if you round
49.0, which leaves us with one
grams.
extra question. This is this is the annoying part. This is the annoying question now. What you want to do now is answer this question. How much excess is left over? So to do that, you take this number here and you go over here. And what would that number
Subtract
be?
it.
Well, you got to be careful here. You have to do the ratio. You have to multiply by a third. See, it's 1/3. 1/3. You see the 1/3?
Yeah.
So what's 4.312 times a third?
4.312 times 1 over 3. It's 1.4737.
1.474 is okay? Is that okay?
No, I got 1.437. Oh, never mind. Yeah, right.
Are you sure it's 1.474? We need this number. I don't want to be wrong.
No, 1.437.
Yeah, 1.437. Thank you. Sorry, because I'm not using my calculator. I'm just kind of doing it on the fly. So I'm going to write a little couple sentences at the bottom here, and then this will solidify the last part of the question, okay?
Okay.
So this is a nitrogen, okay? We have 1.467 moles of nitrogen. We consume 1.437 moles of nitrogen. So, therefore, we have 0.030 moles of nitrogen left over.
Left? Yeah.
Because remember, you had 1.467. In order to complete the reaction, you consumed 1.437. And if you subtract the two, that's the leftovers.
Yeah.
Okay? And then just convert that to a mass and you're done. So I'll do the conversion right here. So we'll do 0.030 moles. What's the molar mass of nitrogen? Well, we have it up there. It's 28.
Yeah, 0.02.
0.02 grams per mole. Can you multiply that out, please? Just two significant digits because we have very little accuracy here.
30 times 28.02
I got 0.10.
over.
That's what's left over.
Wait, how many moles are you dividing it by?
No. This is the molar
At the
mass.
bottom.
That's the molar mass, Angie.
Oh, grams per mole. I see.
That's the molar mass, okay? It's the 28.
Okay.
All right.
Yeah.
That's how you do excess and limiting. You
Okay.
understand?
I'm gonna read you one of her questions because like it's a lot. Like it's not as simple as that.
Mass. You're going to see what I'm saying in a second. Mass, molar mass, and moles. 4.46. This stuff I don't care, and this stuff I don't care. It's already balanced,
Okay.
so I'm not going to balance it because they balanced it for you. I need the molar masses of these. Can you give me the molar masses of these, please?
Okay. AlCl3 is 133.3 grams per mole.
And what's the other one?
And then sodium chloride is 58.44 grams per mole.
Are you sure about those?
Yeah. Yeah, because we did it yesterday in class. So
Okay,
like I
look
have it
here.
written down.
Look, we're trying to find this, right?
The mass, yeah.
Yeah. Was it different than this question? It's the same thing. It's the same thing.
Okay.
It's the same thing, kid. How do you go down the table?
Divide.
Divide them. Go ahead. I got 0.0335.
Yeah.
Okay. How do you go from here to here?
Multiply.
By 3.
Because the thing in front of the sodium chloride is 3, right?
Yeah, because it's 3 over 1. 3 to 1 ratio.
Yeah.
And then how do you go up the table? How do you
Multiply.
Multiply your answer by 5844. 5.87.
Okay.
Done. Next.
Yeah, that's what I got. That's what the answer was.
So that's it.
No. But she made us do something. It was so confusing. She goes, so like there's like 3 steps she gives us. You have to like.
She's writing steps down, formulas.
Yeah, it's like NaC. You have to find like the something first, and then it was so confusing. Like I was
writing it. She's writing it as a procedure, Angie. She's writing it. She's saying, get the molar mass, get the moles, get the moles, get the molar mass. She's making you write down 5 or 6 steps. That is the equivalent to what I'm doing with the table here. If you write it as a table, every question's a joke. I'm telling you. Every question's the same.
And then there was one. Okay. One of them was like, these calculations can be extended to determine the number of particles, blah, 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 using Avogadro's constant. So we had to use it for one of the questions.
Yeah, you're just converting moles to atoms. Who cares? That's nothing.
It's balanced already.
Now it's balanced. The HCl needs to be doubled.
Yeah.
Let me walk you through this. Another table. Okay, every time it's a table, Angie. Every time it's a table. 60 grams of magnesium Molar mass of magnesium, 2.468.
Yeah.
And then it says how many hydrogen molecules? It's a 1-to-1 ratio. That's so boring. Okay, so for this question, they don't want you to find this. They just want you to convert this to, this is moles. They just want molecules. So the answer is 2.
Yeah, they want the entity.
Sorry? You
Oh,
just have to multiply by
it says
Avogadro's
like
number. That's it.
yeah.
So what's it? That's the answer. Done.
Okay.
It's not asking for grams. So just multiply by Avogadro's
Okay,
number.
so we just do this times. Okay, I see. And then the answer was like 1.49
This question,
times
honestly, it's a good
24.
question, but this is not practical. No one's gonna ever ask you how many molecules.
Yeah.
Okay? That's like, honestly, focus on just doing the gram stuff at the end. You're gonna have to know a couple of these for a test, but then you're never gonna see it again. So don't worry about it. Not
Okay.
molecules. Sorry, times 10 to the excess limiting question is the one that you should be studying the most. You're gonna get a bunch of these, and the thing is that it's just this over and over again. Now the difficulty is that your teacher is going to give you a quiz or whatever, and it's going to be like maybe 10 of these. And if you try to write a table for them, you're going to waste a lot of time being pretty. You have no time to be pretty here. Don't draw pretty lines and all this crap. Draw, see, how fast did this table take me long to draw? No, 10 seconds, right? Took me 10 seconds. I drew some lines and I crossed out the stuff I don't care about.